All right, Algebra 1, here we go. We are looking at Unit 5, which is linear equations and systems of linear equations, which means we're going to have not just one equation that we're going to work with, but two. But to start out with, let's do a quick warm-up over section 5.1 is going to have a warm-up, kind of just to get us ready with some of the things we're going to need, as well as we don't want to forget them. So starting out with a warm-up, solving equations. We have the first one. Looking at it, here's your equal sign, so we know we're solving, and it also tells us we're going to solve. Put a line down that middle, of course, and then start on the left-hand side here and see if we can simplify that. So I see a -3 outside of parentheses. Let's go ahead and distribute because there's nothing to do on the inside. So I've got 2k minus 12 plus 3k. And the other side would just come on down. So I still have my 3k plus 4. There's my equal sign. Now let's see if we can combine like terms. So we did distribute. Oh, the pen is not liking it today. And then we're going to combine like terms. And then we're going to move things around. So starting out, we're going to combine like terms. I've got 2k plus 3k is 5k minus 12 equals 3k plus 4. Now let's move our variables. So move variables. I'm going to move my variables left. And then I'm going to move constants right. So keep on going with this. I'm going to minus the 3k minus the 3k. I end up with 2k minus 12 equals 4. And now we're going to add 12 to both sides. So I end up with, running out of space here. So I get 2k is equal to 16 divided by 2. K is equal to 8. Number 2. This one has a proportion because I have two fractions that equal to each other. So that's going to be a proportion. And we're going to cross products or equivalents. We're going to multiply crosswise. I'm going to say 8 times x plus 2 is going to equal 3 times 3x minus 4. So cross products are equivalent. Now I'm going to distribute. So on this next one, it was cross products are equivalent. So cross products are equal. Then we're going to go through the same process, distribute. So I end up getting 8x plus 16 equals 9x minus 12. There's nothing to combine, so we're going to move variables left. So minus 9x minus 9x. If you can see that you can do both of these at the same time, you could also move your plain numbers, your constants at the same time. So moving these away, and I move those away. So I ended up with negative 1x is equal to negative 28. Divide by negative 1 on both sides, and I end up with x equals 28. And the last one is just distribute. It says just distribute. So I'm going to multiply by the top and divide by the bottom. So I'd end up with 1 times 30x, which is 30x, divided by 5 gives me 6x. And 1 times 15 is 15, divided by 5 is 3. If I let's go ahead and lock this in place. There we go. If I block this, group them. I can move that down here. another way of throwing the same thing, if I wanted to throw out that work, it would be 30x divided by 5, which gives me 6x, plus 15 divided by 5, which gives me 3. Okay, number 4, which one does not belong? Explain why you chose the one you did and why. So go ahead and you can look at them and you tell me which one does not belong. So this is on your own. Thinking about solutions, again, go ahead and this one says it's true for all values. Go ahead and simplify it out, and we'll talk about this in class. These, it is a warm-up, so I need to do them on your own. And the next page. Here's where we're actually starting in with solving systems of linear equations. So as we get into solving systems by graphing, I'm going to say, what does linear mean? Let's talk about what linear means. Well, linear means it has a straight line. Okay, so it makes a straight line. Okay, so then what is a system of linear equations? It's going to be more than one in the same, more than one line. In the same coordinate. Graph. Okay, so more than one line in the same coordinate graph. So when I'm looking at a graph, when you have a graph, a linear equation, what do you make? Well, and what does it represent? Okay, well, this whole line, this line that we made, we make a line of solutions. We make a list of solutions. So anything that's on this line is actually a solution. So we make a symbol to show solutions. So what are the possibilities? Well, if you graph two lines on the same coordinate grid, you have some options. Okay, so two lines are either going to, number one, that's what we've been doing, they're going to cross. So if they crisscross, where they crisscross is the solution. So cross and have one solution. And that one solution is going to be represented with an X and a Y. The second option would be that you never touch. So touch, which means no solution. And that means because they are parallel. And the third thing that could possibly happen is that it is one and the same. So this line is actually on top of it. It is the same line. So same line. And it's going to have infinitely many solutions. Now, along with that, we've already learned a few things about lines previously, but if they cross, they're going to have different slopes. Now, in option 1 or 2 and 3, they have the same slope. And this one also has the same slope. But, little note to self, these have to have different y-intercepts. So where they cross the y-axis is different. Here, they have the same y-intercept. because they are the same line. So it crisscrosses here. So now, is an ordered pair, -3, 1, a solution to the system? Justify your answer. Well, if 3, 1, this is my x and this is my y. If it's a solution, it means it works for both equations. So a solution work in the equation. In other words, it makes a true statement. So if I put it in and I solve it, if it makes a true statement, then yes. So if I put in a -3, so -3 plus 1 equals -2. -2 equals -2, that's a yes. Plug it into the second one, so that was this one. Plug it into the second one, -3 plus 5 times 1 equals 2. Well, -3 plus 5 equals 2. 2 equals 2. So yes, it is also a solution. So if it works in the equation, it is a solution. It's a solution of the first one and a solution of the second one. So now it is of the system. So yes, it works in both equations. So it is the solution. Use a graph to solve the system and check your solutions. So if I'm looking at this, the first equation is graphed here, and the second one is graphed here, I believe. Oh, I think that's supposed to be a negative down there. Let's double check that. Yes, this is supposed to have a negative on it. Let's put a little negative down there. All right. So if I were to look at this, it tells me my solution would be right there, which is at 1, 2, 3, 4, 5, 6, -1 is where it looks like it crosses. I'm going to plug in 6, -1 into the top equation. So 2 times 6 plus 5 times -1 equals 7. And then the other equation is going to be negative the 6 plus 2 times -1 equals -8. So solve both of them, and if they come out true, then it is a solution, even though sometimes with graphing, it doesn't always look right. So this is 12 minus 5 equals 7, and 12 minus 5 is 7. So 7 equals 7, it is true. Check. The other one over here is -6 minus 2 is -8, and -8 does equal -8. So check. It also is true. So yes. Okay, then there are 3 ways to solve a system of equations. The first way is to create a graph. So as we look at this, we're going to try to graph these. All right, so as I look at this, I need to graph it. First of all, the best way to graph is through standard form, or either slope-intercept form or standard form. I'm going to go with slope-intercept form. Sometimes you can use standard form, it becomes nice and pretty, but I'm going to go ahead and rearrange both of these. So this first one, I'm going to say minus the 2x minus the 2x. I'm going to end up with y equals -2x plus 2. So that would be up to, put a dot. I'm going to go down to right 1, down to right 1. And I'm going to kind of keep going on this whole pattern, almost all the way across my grid. Because that is how it's going to be the most accurate, especially if I want to touch another line on the same grid. So that is my green line, basically. Now I'm going to go ahead and actually I will make a line, but right now I'm going to go ahead and do the other equation. I'm going to go ahead and minus an x, to get y is equal to -x plus y. Oops. 1, excuse me. So just bring it off to the edge. I'm going to go up 1, put a dot. And from that point, I'm going to go down 1 over 1. Down 1 over 1. Ooh, I already found my solution. Down 1 over 1, down 1 over 1. And I keep going with that pattern, so it's nice and tidy. And also I'm going to go up and back, so I can extend my line. I can already tell where it crisscrosses because I say it crisscrosses right there. They overlapped on that same point. So it would be 1, 0. 1, 0 is my solution. And then I can check my solution by putting it into my two equations. So I can say the y value is 0. So 0 plus 2 times 1 is equal to 2. Well, 2 equals 2. That is correct. And then the other one, I'm going to plug it in and say the x value is 1. So 1 plus 0 is equal to 1. 1 equals 1. And that is true. And I do like it when you make nice pretty lines, but sometimes it's kind of hard to draw nice straight lines. I recommend that if you're using Vintage, switch the colors up. It'll make your life a lot easier. There you go. Next one. Solve the system by graphing. These, I'm really being nice. You put them in slope-intercept form already. And so as you look at this, just go ahead and plot the y-intercept. Use your slope from that point. So up 1, put a dot. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Or exact reverse would be down 1, 2, 3, back 1. Down 1, 2, 3, back 1. Down 1, 2, 3, back 1. Down, oops, I'm off the grid. And then, so I did that one in pink. I'm going to do the other one in purple. So it's going to be up 5, 1, 2, 3, 4, 5. And from that, I'm going to go down 1 over 1. Oops, I already overlapped. Down 1 over 1, down 1 over 1, down 1 over 1. And I go up and back. I already found my solution. My solution looks like 1, 1, 2, 3, 4, 1, 4. And I can just check my solution. 1, 4 into up here. So it's going to be 4 equals 3 times 1 plus 1. So it's 3 plus 1. So 4 equals 4. Okay. And the other one I'm going to check is 4 equals negative the 1 plus 5. So negative 1 plus 5 is 4. And 4 equals 4. Go ahead and make your pretty line so that everything's all good. And the next one. And keep in mind, as you look at this, you can see the slopes are different and the y-intercepts are different. We know it's going to crisscross, obviously. Up here, when I rearranged them, I had a -2 and a -1. So I knew that they had different slopes, so they were going to intersect. This next one, let's rearrange it first. If I rearrange the first one here, I'm going to end up minusing the 3x, minusing 3x. So I get y equals -3x plus 4. Up 4, 1, 2, 3, 4, put a dot. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1. And in reverse, up 1, 2, 3, back 1. Back 1. And then I'll do this other one in red. For some reason, I've made the 8 in red. I'm going to take away x. I end up with -2y equals -x minus 8. And divide by -2 on everything. I get y equals 1/2 x plus 4. I'm going to go up 4, put a dot. 1, 2, 3, 4. Ooh, look at that. My y-intercept is the same. Down 1. All right, and so I already have that. So I'm going to go up 1, up 1 over 2. Up 1 over 2. I'm also going to go down 1, back 2. Down 1, back 2. My solution, it looks like, is going to be 0, 4. And then check your solution for me, please. So it's going to be 4 is equal to 3, -3 times 0 plus 4. So yes, 4 equals 4. And the other one is going to be 0 minus 2 times 4 is equal to -8. -8 equals -8. That is true. And you have one more to do on your own. I will tell you the solution, and I want you to work toward it. The solution is 1, 3.